In the last two sections, we learned the mechanics of number systems and familiarized ourselves with two new number systems, binary and hexadecimal. In this section, we're going to connect the dots between number systems and coding by exploring how computers store information. When we think about how computers store data, we probably think about things like gigabytes. But what is a gigabyte? Well, it turns out a gigabyte is 1,024 megabytes, and a megabyte is 1,024 kilobytes, and a kilobyte is 1,024 bytes, and a byte is 8 bits. So, what is a bit? A bit is actually an abbreviation for binary digit. That means that a bit is literally just a 0 or a 1. But how can computers store complex information if the only type of data they understand is binary digits, zeros and ones? For instance, how could a computer store my name? Actually, how could it even store the first letter of my name? Maybe I could create a system where if any bit is set to 1, it means Z. Although it wouldn't be able to distinguish between other letters of the alphabet because a bit only has one other value, 0. So clearly a single bit is insufficient. But what if we group bits? What if we were to group them by, I don't know, 8? And let's give this group of 8 bits some arbitrary name like byte. This byte is an 8-digit binary number. And how many different values can an 8-digit binary number have? We know from the last section that it can have 2 to the 7th plus 2 to the 6th plus 2 to the 5th plus 2 to the 4th plus 2 to the 3rd plus 2 to the 2nd plus 2 to the 1st plus 2 to the 0th unique values. In fact, this equals 2 to the 8th. So an 8-bit binary number can have 256 different values. Our alphabet only has 52 different values, 26 uppercase letters and 26 lowercase letters. This means we could uniquely encode each letter of our alphabet into a byte. We could encode capital A as 1, capital B as 10, capital C as 11, and so on. This is in fact the approach that is taken to encode data like characters. There are a number of different character encoding tables, but the most popular is the ASCII table. Take a minute to encode your name into hexadecimal and/or binary numbers using the ASCII table. For example, my name encodes to 5A616368 in hexadecimal and 011010011000110110001000 in binary using the ASCII encoding table. 8 bits may be plenty of storage for a single character, but what if we want to encode something more complex, such as a really large number like a billion? Well, just like we can group bits, we can also group bytes. Common practice is to group either 4 or 8 bytes of data at a time. The reason has to do with the physical hardware of computers. Have you ever had to check whether your computer is 32-bit or 64-bit? That's because some processors can handle 32 bits of information at a time, while others can handle 64 bits of information at a time. Most modern software uses 64-bit numbers and data, so when that software runs on 32-bit processors, it has to kind of fake it. That's why it's important to download 32-bit versions of software if you have a 32-bit processor, so that software knows it needs to fake 64-bit data. Fundamentally, coding is the encoding and decoding of information to and from bits on a computer. This information can be data or it can be instructions for the computer to execute, and it's all facilitated by the programming language we choose to code in. A programming language, then, is a kind of translator between us and the computer. In this course, we're going to code in the JavaScript programming language. JavaScript is a very friendly language to learn as a beginner, and it is also the language of the web, which means by learning JavaScript, we'll be able to build dynamic, interactive websites.